At New River Air Station in North Carolina, Marine Corps Squadron 266, aka the Fighting Griffins, are preparing for a complex training mission.
Got radio, Sidewinder. That looks like you're ready to rock and roll, sir.
It's designed to test their ability to overcome the challenges of modern military operations.
In today's battlefield, it's constantly changing. We never know what operating environment we're going to have to confront, whether that's the desert, urban environments, or Arctic weather. Confronting America's adversaries, we need to be able to understand, decide, and act. Our ability to do that quickly and act quickly with adaptability and flexibility will be key to our success.
And when it's time for the Marines to enter the action, they can rely on an aircraft that's capable of the ultimate adaptation, one that was long thought impossible. This is the V-22 Osprey, a revolutionary feat of aviation engineering that combines the speed and range of an airplane with the land-anywhere capability of a helicopter. It's a multi-mission powerhouse that allows the U.S. military to perform crucial operations in challenging conditions all over the world.
This aircraft, in my opinion, defines the 21st century Marine Corps.
The Osprey is truly impressive. When I look at it, I'm blown away by the technology and the capability it's able to produce.
The MV-22 can fly as high as 25,000 feet and hit 280 knots. We can carry 12,500 pounds externally and has a range in the ballpark of 750 to 800 nautical miles.
Nothing can compare to the Osprey. It's one of a kind, and I love it.
Equipped with a pair of 38-foot rotors, the Osprey can take off vertically like a helicopter, pivot its blades forward, and transform into a propeller-powered airplane. Capable of carrying 24 fully loaded combat Marines and slinging the equivalent weight of an African elephant beneath the fuselage. It's the ideal aircraft for flying troops and cargo into tough-to-reach, often dangerous locations. For Marine Colonel John Spade, the Osprey is an invaluable tool that's helped redefine how his teams can operate.
Our ambition as Marines was to be able to project power well forward. The V-22 Osprey was created to achieve and accomplish that ambition. This aircraft is giving us a capability we've never had before by combining both an airplane mode and a helicopter mode, which allows us to quickly respond to emerging situations that are in front of the Marine Corps right now.
And this game-changing machine is pushing the boundaries of what's possible for American armed forces.
Unlike any other aircraft, we can take off vertically, transition airplane mode, get to great distances at great speed, and land vertically again. This allows us to get in those austere locations quickly and with great response.
Engineers have built a world-class aircraft with matchless capabilities. But how do you design a vehicle that can transform from helicopter to airplane in flight?
The capabilities of a fixed-wing aircraft and the capabilities of a helicopter are completely different. Combining those capabilities into a single airframe is particularly difficult.
How do you keep the aircraft under control while it shapeshifts in mid-air?
You have centers of gravity shifting, you're operating in different speeds, so the characteristics of this aircraft are constantly changing.
And how do you stow a giant aircraft in the cramped spaces on board transport ships?
So we have to be able to fit a high number of V-22s onto our amphibious shipping, so it's important that we can fold it and fit it into tight spaces.
Operated by a crew of 4 Marines, the Osprey accomplishes all this and more. It's powered by a pair of Rolls-Royce engines that can propel it over 300 miles per hour. A top speed more than 50% greater than the planet's fastest helicopter.
We are still above 20, kill 3.
Roger, kill 3.
The Fighting Griffins are making their final preparations before taking to the skies on today's training flight.
Please check this reviewed. Complete.
But this military exercise is only possible thanks to some of the most groundbreaking aviation engineering the world has ever seen. Responsible for a few world firsts, this revolutionary aircraft never fails to amaze Osprey engineer Rod Olson.
The Osprey is designed to take off like a helicopter and fly like a fixed-wing aircraft. It then lands like a helicopter as well. The capabilities of a fixed-wing aircraft and the capabilities of a helicopter are completely different. Combining those capabilities into a single airframe is particularly difficult because you have to balance design requirements in order to achieve an optimum solution. The mechanics and physics involved in solving the transition between helicopter mode and airplane mode are particularly complex.
In order to solve this problem, engineers can look to history's innovators for inspiration. At the National Museum of the U.S. Air Force in Dayton, Ohio, aerospace engineer Lynn Pickering has traveled to see a game-changing experimental aircraft.
Oh my gosh, look at this thing. It looks like it's straight out of a sci-fi film. This is the Bell XV-3. It's the only one left of its kind. I would have to say this is one of the most exciting pieces of aviation engineering that I've ever seen.
Making its maiden flight in 1955, the XV-3 is a true pioneer of aviation engineering. Developed as part of a joint research program between the United States Air Force and Army, the experimental concepts introduced on the XV-3 laid the foundation that helped make the Osprey possible.
This aircraft is actually the first attempt at tiltrotor technology. And so what that means is that this is in helicopter formation now, but when the aircraft takes off, these blades rotate down into airplane mode. And then when the aircraft needs to land again, they rotate back up, lands like a helicopter.
These cleverly designed rotor blades allowed for a previously unprecedented mid-air switch.
This is wild. You'd think that something like this should be impossible, that you take off like a helicopter and then you transform kind of like a transformer and then you're flying like an airplane. So it's always been a bit of a holy grail for aviation engineers.
Leading the quest to realize this ambition were Bell designers Bob Lichten and Kenneth Wernicke.
I just think of how daunting this must have been to design something like this. When you're trying to combine those two concepts into one airframe, you run into a lot of issues.
And during a test flight in 1956, the XV-3 would demonstrate just how difficult it is to perfect tilt-rotor technology. After the aircraft suffered extreme vibrations in midair, the pilot passed out, causing the prototype to crash. To solve this problem, engineers needed to go back to the drawing board.
So if we look at the wings, we can actually see one of the key design changes after that first crash.
Their solution changed aviation forever and provided the groundwork for the V-22 Osprey to rule the skies.
The technology demonstrated by the V-22 is really a long time coming and the result of multiple decades of engineering.
The V-22 Osprey is a unique military aircraft with unrivaled capabilities. Equipped with a pair of transformational tilt rotors, the Osprey can convert between flight modes in just 12 seconds, allowing it to take off, hover, and land like a helicopter, and fly at high speed and altitude like an airplane. To make this mighty machine possible, engineers needed to learn from the trials and errors of their predecessors. The Bell XV-3 was the first aircraft to utilize tiltrotor technology, but their test flight revealed a catastrophic vibration issue. Having realized the flaw in their design, Bell's engineers set out to find a solution.
So if we look at the wings, we can actually see one of the key design changes after that first crash. They've added these struts in here to make these wings a lot stronger, and that changed the whole frequency of the structure so that it no longer is going to resonate with this tilt rotor tilting down. And let me show you another aspect of the design change. They actually changed from a 3-blade design up here to 2 blades. And they strengthened and shortened this pylon here on both sides to make this stronger and decrease the vibrations. And then inside this fairing here, we've actually got the electrical motor that completes this 90-degree arc in only 10 to 15 seconds. So very quickly, you're able to go from helicopter mode to prop plane mode.
After incorporating its new design elements, the XV-3 successfully overcame its problems, completing more than 100 full conversions of its tilt rotors between 1958 and 1962, making it the first aircraft to achieve a feat engineers had long thought impossible.
The XV-3 might just be one of the most important pieces of aviation engineering. It really took this concept of combining these two technologies, which a lot of people thought was going to be impossible, and they proved that it was possible.
Crew to takeoff runway 23-24. Gonna request an airplane departure.
Back on board the Osprey,
Runway 23, we'd like the left turnout for hospital point departure. Broker.
today's expert flight crew is about to embark on their scheduled training mission, which will test the aircraft's unique faculties. Just like the XV-3, the Osprey uses its rotors in the upright position to take off vertically, then pivots them forward by 90 degrees, allowing the wings to generate lift, completing the conversion to propeller plane in a little over 12 seconds. Osprey engineer Rod Olson knows just what it takes to make this remarkable feat possible. The secrets behind the incredible tilt rotor technology are hidden inside the structures on the aircraft's wingtips, known as nacelles.
So contained within the nacelle, there are several components that allow it to operate. Primarily the engines, which are in this lower portion. Then there are gearboxes further up, drivetrains, and ultimately the rotor system here at the tip. The pylon conversion actuator is responsible for actually moving the nacelles up and down. It has dual redundancy, so in the event of a failure, the pylon conversion actuator can actually allow the aircraft to land safely.
The pylon conversion actuator is a hydraulically powered telescopic ball screw. As the screw is rotated, it extends and rotates a lug that is coupled to the nacelle, causing it to pivot from the vertical to horizontal orientation. When the screw is rotated in the opposite direction, the nacelle returns to the vertical orientation.
If you look at the nacelle and the tilt rotor, you can see just how impressive the engineering is that went into this. The tilt rotor technology employed on the Osprey is unique. It is not used anywhere else in the world in an operational status.
Surprisingly, all it takes for Osprey pilots like Major Thomas Cecil to carry out this incredible transformation is the push of a single switch.
The V-22 makes the transition from helicopter mode to airplane mode with really just the flick of the thumb. On our TCL down here, we have a nacelle thumb wheel, and all we have to do is push forward on the thumb wheel, and it begins to actuate the nacelles forward towards airplane mode. So when I push forward on the nacelle thumb wheel, It's going to actuate conversion actuators on either wingtip, and through the conversion actuators, it'll modulate the nacelles down. When we're ready to convert again and come back to VTOL, it's just a reverse process. We'll pull back on the nacelle thumb wheel as we revert back to typical helicopter-style controls.
It's a groundbreaking achievement that's only possible thanks to the Osprey's innovative aviation ancestors.
The technology demonstrated by the V-22 is really a long time coming and the result of multiple decades of engineering, and it all starts and is all built off other aircrafts.
Back in the sky,
200 feet, gear 3 down, locked.
266 Squadron is underway on a training exercise designed to simulate the challenges of a complex, real-world military operation.
Copy, 80 feet, all calls at the back. Roger, clear right.
With the Marines regularly deployed in the planet's most hostile locations, it's essential that the Osprey can get them there safely.
Dust building.
And that means being able to land in low visibility conditions.
And brakes, heel, to the deck.
We have to be able to take this aircraft into any environment, and because of the amount of downwash that we create, we have to be ready for dust, sand, snow, anything, and that's going to reduce our visibility when coming into land. Losing visibility during landing is extremely dangerous. If you can imagine pulling into your driveway with your eyes closed while you're driving your car, do you just trust yourself to just stop before you crash into your garage door? But in this case, we have maybe up to 25, 27 people's lives on the line and very expensive equipment. If we were to crash an aircraft, that right there is mission failure. So it's very important that we're able to take off and land in a reduced visibility environment.
Incredibly, engineers have come up with a solution that allows the Osprey to operate in zero visibility, helping pilots avoid disaster.
We have a couple different ways that we can do this. One is through an automated approach, which is pre-built into our flight plan to assist the pilot to make a safe landing. We're really talking about the very final stages before landing, and this is where we're going to lose our visibility outside.
By using GPS technology to identify a suitable landing location, the Osprey can control its drift and rate of descent to safely touch down without any input from the pilot. And the aircraft's high-tech instrumentation can also be used to automate a landing when loss of visibility is not expected.
We can also use automation on the fly, and we engage that utilizing the flight director panel. For the primary piece that we're looking at here is the hover coupler, and utilizing this is going to give us varying degrees of lateral control assistance to minimize drift. It's also going to help us slow the aircraft down and give us a controlled rate of descent. When we're ready to land, we can disengage basically the altitude control, and then we control the altitude and rate of descent.
It's an amazing solution that's essential to allow the Osprey to land in the world's most hostile locations in zero visibility.
It's just not possible without this system and without these displays that we have.
The team has devised a one-of-a-kind multimodal aircraft capable of an amazing transformation, but engineers now face the problem of how to keep it stable while it morphs in midair.
There's a lot of challenges with operating in conversion mode. In order to land, we have to slow down. This involves converting. And as we do this, changes the configuration of the aircraft and brings some different handling characteristics into play.
To help keep the Osprey stable through this unique conversion process, engineers must look to the pioneers of the past.
All right, you ready to go?
Yeah, man, let's go flying.
engineer Dan Dickrell has traveled to the heart of Georgia.
Oh, I can't wait to see this. This is going to be awesome.
To discover a plane with a trailblazing design.
Dang, look at that. What a beautiful and shiny aircraft. It's a Lockheed Electra 12. It's a classic example of Art Deco era of aviation. There's only about 10 of these left in the world, and today I get to fly one.
First taking flight in 1936, the Lockheed Model 12 Electra Jr. is a pioneer of passenger aviation. And it holds the key to keeping the V-22 Osprey stable as it transitions between helicopter and airplane in midair.
It's 7 Lakes traffic, Lockheed departing runway 18, 7 Lakes.
Building on the success of the Model 10 that went into production 2 years earlier, the Electra family of aircraft was famous for its forward-thinking all-metal construction and the early adoption of twin engines.
All right, you ready to go?
Yeah, man, let's go flying.
Come on back.
Oh, this is awesome. Man, what a pretty view. That was one of the smoothest takeoffs I've ever experienced, even in a small plane.
And as Dan is about to discover, the Electra is an aircraft that's remarkably easy to handle.
All right, so you ready to fly?
I am. Thank you, sir.
Airplane's yours.
All right, I have control of the airplane. Oh.
But in the early days of the Electra's development, a flaw was discovered in one of its key components, a defect that threatened to keep the airplane grounded.
When it comes to aircraft control, one of the primary control surfaces is the rudder, the tail, and that's the part that allows the plane to yaw in the sky and go left and right. So much like the steering wheel in a car allows the car to turn left and right, I have two pedals on the floor that I have my feet on, and if I press the left rudder pedal in strongly, there we go, it turns to the left, and if I press my right pedal in, we go to the right a little bit. There we go. Those are the basics.
Initially designed with a single tail positioned in the center of the fuselage, wind tunnel tests showed the Electra was vulnerable to instability in flight.
This is obviously a problem, especially if you're trying to design a passenger plane. So the engineers knew that they had to solve this in order for this aircraft to be successful.
The solution came from an unexpected source, Clarence Kelly Johnson, a student working on the Electra program.
So Johnson realized the problem with the prototype stability came down to the single tail. And his solution was this, a twin tail design.
This simple design tweak was a game changer for the Electra, and it solved the prototype stability problems for good.
The reason why the twin tail works as well as it does comes down to placement. If you can see, the propeller on this side of the aircraft is almost in line with the tail, right? The reason why that helps is because the slipstream that's coming off of this propeller is in a position where it can interact with the control surface, this rudder. And remember, a rudder helps the airplane yaw left or right in the air. In situations where there's low speed, either on takeoff or landing, the ability of this control surface to safely move the airplane around is most important. And that's one of the upsides of this design versus a single tail. Single tail can't take advantage of that alignment and that increased airflow. And so that's why this twin tail works as well as it does. Additionally, since there's two tails, there's twice the area, you have much more control authority to maneuver this plane in the air. It's a brilliant solution.
Over 85 years after Johnson introduced the twin tail on the Electra, the Osprey's pilots utilized the same innovative concept.
The twin tail is what gives this aircraft that directional stability when we're operating in airplane mode. On On each vertical stabilizer, it has a rudder. Those rudders are both actuated utilizing the pedals on the floor of the cockpit, and we use that to control and make directional control inputs. Also in between our two vertical stabilizers, we have the horizontal stabilizer with the elevator, which is this giant kind of whale tail, which you see, and that gives us longitudinal control.
As with the Electra, the Osprey's use of this tail technology is key for ensuring a smooth flight experience.
We have to have a certain amount of stability. Without the twin tails, this aircraft would be much, much harder to fly.
And this stabilizing innovation is also involved in steadying the aircraft through its challenging conversion process.
The twin tail makes it possible for this aircraft to transition between airplane and VTOL. When we're in airplane, all of our controls are actuated similar to any other airplane. And then as we move towards VTOL, everything is made through the similar control inputs to what you would see with a helicopter. In between, it's a combination of the two.
And converting to helicopter mode.
So as we transition from airplane-type control inputs towards helicopter-type control inputs, it's a blend utilizing the tail, whether it be the elevator, the rudders, combined with inputs through the prop rotors to achieve for the overall output and control that we require.
It's an ingenious modern use of this historic technology that helps give the Osprey its one-of-a-kind capabilities. But in order to accomplish its global missions, it needs to be transported long distances inside the restricted space on board an aircraft carrier.
We have to be able to fit a high number of V-22s onto our amphibious shipping, so it's important that we can fold it down and fit it into tight spaces.
To achieve this, engineers can turn to history's innovators for inspiration.
What's amazing to me is how much still is relevant today. It's remarkable.
To transport troops and cargo anywhere in the world.
2 is setting up. Roger.
Engineers have created a shape-shifting military flying machine. Part helicopter and part airplane. The V-22 Osprey is the ultimate aircraft. Fitted with 3 fuel tanks in the fuselage and 2 more integrated in the wings. The Osprey can hold close to 1,500 gallons of fuel, around 75 times more than a family car, and enough to fly non-stop from Miami to Philadelphia. In the skies above North Carolina,
Tell right to land on the Delta taxiway.
the 266 Squadron flight crew is returning to New River Air Station, having just completed a successful training flight.
Firm 3 down and lock. Just so you know, I got Blackburn on top radio, I got Blackburn. Copy. Blackburn 30 feet. Tower clear, right? One's on deck.
But for the Osprey to carry out its worldwide missions, the aircraft must be able to travel distances far beyond its flying range.
So the Marine Corps, as our nation's force and readiness, it's important that we have an aircraft that can operate in any place around the globe. So it's extremely important that the V-22 be able to fit and operate off of existing amphibious shipping. We have to be able to fit a high number of V-22s onto our amphibious shipping that has limited hangar space. So it's important that we can fit it into tight spaces.
But squeezing an aircraft measuring 84 feet wide into a restricted footprint presents a potentially impossible problem.
The size constraints the Osprey has to fit in are approximately 20 feet wide by 20 feet tall by about 63 feet long. It's a significant design challenge to combine all of the details of the Osprey into the small footprint while still meeting critical flight characteristics.
To find a solution, engineers must seek inspiration from the pioneers of the past. In San Diego.
Oh my gosh, this place is absolutely massive.
Helicopter pilot Micah Muzio is on board an iconic aircraft carrier, the USS Midway.
It's incredible to be standing here. This is 4 acres of floating aviation history. Can you imagine what this was like back when active? The sound of the jets, the spinning of the blades, all that activity.
Commissioned in 1945, the Midway was once the largest ship in the world.
As an aviation nerd, it's cool to see all the aircraft, but putting them in the context of an actual aircraft carrier really brings it to life.
But even the Midway's hangar space was limited, and aircraft with large wingspans or propeller blades are not easily transported. The Navy needed a way to maximize the number of aircraft per carrier. Thankfully, in 1943, engineer Michael Boyvid helped design a helicopter equipped with an ingenious solution that would redefine how aircraft are transported.
Look at this thing. It's amazing.
This is the Sikorsky H-5, also known as the Dragonfly.
From a pilot's perspective, when I look at the cockpit, I just think the field of view is incredible. You can just see in all directions.
But the view is not the H-5's greatest accomplishment.
What's amazing to me is how much still is relevant today. There's so many components on here that just worked, and we've stuck with them.
And the innovative engineering behind this groundbreaking aircraft is exactly what the V-22 Osprey team has been looking for.
To me, this folding mechanism is a real game changer. That's really incredible.
The V-22 Osprey is one of the most remarkable machines on the planet. Built to carry troops and cargo at high speed over long distances and into hard-to-reach locations, it can achieve the seemingly impossible by transforming itself from helicopter to airplane in midair. But each individual aircraft has a huge footprint, making them difficult to transport and store. To solve this problem and maximize the Osprey's potential, engineers are looking to the Sikorsky H-5, a pioneering helicopter that inspired the team behind the Osprey.
So the H-5 was special because it was very high performance, flew up to 21,000 feet, which is something I've never done in a helicopter. What's amazing to me is how much still is relevant today. There are so many components on here that just worked, and we've stuck with them. It's remarkable.
Built to offer the armed forces a helicopter that could carry greater loads and fly longer, faster, and higher than previously possible, the H-5's impressive performance allowed it to become the first helicopter to operate in the Antarctic. But arguably the most important of this exceptional aircraft's features was its revolutionary rotor blades.
Look at these blades. They take up so much space. It's like a big ring all the way around the helicopter. That's really inefficient use of space, especially if you have the confines of an aircraft carrier. We're in a hangar right here. There's not a lot of space. The rotor system, it's roughly 50 feet in diameter. And if you get two of these side by side, that's 100 feet of space that you're taking up just because of the rotor size.
But as Micah is about to discover with help from the carrier's crew, These blades can perform an innovative feature to solve the problem.
So the first thing you're taking out, that's the pitch link bolt.
The pitch link, it controls the pitch of the blade.
Okay.
Now what I'm going to do, I'm going to rotate it, so basically I'm going to change the pitch on the blade.
Okay, we're going down.
Going down. Now he's going to pull the wing or the blade attach bolt out so that we can swing the blade.
Gotcha, and that lets the whole blade rotate back.
Yes.
Okay. Here's the moment where I hope not to drop it. Okay. Oh, and it just rotates back like that. Okay. That seems pretty easy. Okay, just walking it back. Okay.
After removing just 2 bolts, the blades are ready to fold, allowing the H5 to be totally transformed in a little over a minute.
Okay, coming down a little bit.
So we're going to drop the blade down.
Okay, drops down.
Slide it up into the cradle.
Slide it up. And then 2 bolts back here for the little clamp, and it's good to go. When they started bringing the H5 onto ships, they would just fold them back like this, and this is how you'd store them.
Yeah, except for back then, you had 2 20-year-old sailors doing it.
So a couple of old guys like us.
And after repeating the same process on the opposite side of the aircraft, the H5 can complete a feat that had previously been impossible for a helicopter. By fully folding its blades, the H5 significantly shrinks its footprint.
All right, now what I'm going to do is I'm going to rotate it a little farther to where I can drop it out.
And coming down a little bit. Okay. I'm not going to say there's a lot of pressure here, but this is a very old helicopter, and the guy holding the blades, don't want to break it. Got that. There we are. It is remarkable, though, that just a few seconds ago, this thing was ready to fly.
Yes.
Well, ish. And now here we are. Okay. That was suspiciously easy. I think I'm ready to join the crew, guys. I'm ready to join your squad.
Boyvid's transformative blade fold design helped revolutionize the transport of military aircraft, dramatically reducing the space required to carry a helicopter.
What's incredible to me is that we've gone from 50 feet wide to 5 feet wide in about a minute.
And today, blade folding is still an essential feature on an array of modern aircraft, proving the importance of Boyvid's ingenious invention.
To me, this folding mechanism is a real game changer, making it possible to fly a helicopter from a shipborne environment. That's really incredible.
To complete the V-22 Osprey and make one of the most versatile aircraft in history, engineers will take Boyvid's brilliant solution
It's amazing to see such a massive aircraft turn into such a small footprint like this.
and make it all their own.
This is the world's first complete blade fold and wing stow system.
Today in North Carolina, the V-22 Osprey's engineers have taken Michael Boyvid's blade fold innovation and modernized it to achieve a new feat in aviation.
This is the world's first complete blade fold and wing stow system. There are other platforms that use a portion of blade fold or a portion of blade stow, but in no cases is there a complete process all in one aircraft.
Unlike the manual fold method designed for the H-5, the Osprey's unique system is entirely automated.
At the start of the blade fold sequence, the swash plate actuators that control the rotor head move to the fully retracted position. This causes the blades to pitch vertical. The aircraft then folds the outer two blades so that they join the blade that's currently over the wing. Once that's complete, the nacelles begin to rotate down into the horizontal position, and in doing so, the wing also begins to rotate.
Once the wing has completed its rotation to sit parallel with the airframe, the operation is complete, taking approximately 90 seconds to shrink the Osprey from 84 feet wide to less than 19 feet wide.
The execution of the blade fold wing stow is like a party trick. It's amazing to see such a massive aircraft turn into such a small footprint like this.
It's a remarkable transformation that's vital to the Osprey's functionality, allowing the aircraft to operate from the confines of an aircraft carrier.
The blade fold wing stow system is essential to the success of the Osprey.
This feature, along with the V-22 Osprey's other unique capabilities, make this extraordinary aircraft one of the most advanced machines ever to navigate the sky.
Every day I look at the Osprey, I can't believe how amazing it looks. The engineering that was involved to design this aircraft blows me away.
It's an extreme honor and privilege for me to be part of this Osprey team, not just for this fantastic aircraft, but also to work with those men and women that keep this aircraft flying.